Hello, this is part 2 of my examples for how to do stoichiometric calculations. In the first part, we looked at how to do moles to moles calculations and also how to do moles to mass calculations. One thing that I want to remind you is that in every single one of our stoichiometric calculations, the thing that each one has in common is the presence of a mole to mole ratio. So it doesn't matter if it's the simplest mole-to-mole calculation or any other, every single stoichiometry problem has the mole-to-mole ratio. Also, every single stoichiometry problem is interested in two things. Something that you know information about, which is associated with a number. I like to refer to that as A, and something that we're trying to find information out about, and I like to refer to that as B. So let us look at the third type of stoichiometry calculations called a mass to moles. And this is the reaction. We have ammonia, NH3, combining with oxygen to produce nitrogen monoxide and water. And this equation does need to be balanced, so I'm going to bring everything up on here before I get the pen. And after belaboring over this balanced chemical equation for quite a while and making a recording in which I realized that I wasn't balancing it very efficiently, I'm just going to share the results of that. In this chemical equation, we are going to have 4, I don't like that. Will it erase? It's not erasing. Let's go back. I would like to change my pen color to blue, 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 blue. So we need 4 ammonias, which would need to give us 4 nitrogen monoxides. With this, we have 12 hydrogens, so we need a 6 here. That gives us our 12 hydrogens. Now we have 6 oxygens plus another 4 oxygens, gives us 10 total oxygens on this side. So we will balance that with a number 5 for the coefficient for oxygen, and it is balanced. Okay, the first step after balancing is to figure out what's given. We look for the number. Oh, there it is. And find out what it's associated with. So ammonia is my substance A in this equation. And I'm going to write that down, 824 grams. So we are starting with mass of ammonia. And what is it that we're trying to find? Giving us some room over here, equals how many moles of nitrogen monoxide? Moles of nitrogen monoxide. So nitrogen monoxide is our B substance in this problem. Okay, so nitrogen monoxide. And I do need to include the units, which is moles of nitrogen monoxide. All right, so we're going from grams, which is mass, to moles, which makes this a mass to moles calculation. Now down here I do have the roadmap for this, and I have already done the grams of substance A, which is ammonia, and the next step is a conversion factor in which I have 1 mole of A on the top, 1 mole of ammonia, and I have its molar mass on the bottom. Now, nitrogen is 14.01, and each hydrogen is 1.01, so we have 3.03 for all 3 of those hydrogens, which gives us a total of 17.04. So we have 17.04 grams in 1 mole of ammonia. Our grams of ammonia cancel. Okay, got that conversion factor down. The next conversion factor is our mole to mole ratio. And in this, we have moles of A, which is moles of ammonia, NH3 on the bottom, and moles of B, which is NO on the top. And I am going to draw the little boxes because they make me happy. In front of the ammonia, I have a 4. And in front of the nitrogen monoxide, I also have a 4. Now my moles of ammonia cancel. Now I need to punch this into my calculator. And I have 824 times 1 divided by 17.04 times 4 divided by 4 is 48.3568. So I have 3 sig figs here. So I am going to take that 45.3568 and so on and round it to 48.4. moles of nitrogen monoxide, and there is the final answer for that one. Okay, now we have another question. Oh, this conversion factor has been used and we have gotten our answer. Now another question is how many moles of water are formed. So we have the same starting substance. Now I'm going to go ahead and switch the pen color, and I will make this one red. So how many moles of water are formed? I'm going to start with the same thing. We have 824 grams of ammonia. So in my second problem, ammonia is also my substance A. 824 grams of ammonia. And I'm trying to find moles of water. So equals moles. Pen's not working very well right now for some reason. Moles of water. Okay, so again we have a mass to moles problem. In this case my ammonia is A, but in this my water is my B in this calculation. So starting with grams of ammonia, my first conversion factor is 1 mole of ammonia over the molar mass, so 1 mole of NH3 over the molar mass, 17.04 grams. Okay, I have done these 2 steps. Next is my mole to mole ratio. Where I have moles of A on the bottom. A is ammonia, NH3. And I have moles of B on the top, which is H2O. This mole to mole ratio is always kind of like a bridge between what we start with, our A, and what we end with, which is our B. Now looking at the coefficients, I have a 4 in front of the ammonia. In front of the water, I have a 6. And I have done this. My grams of ammonia cancel, my moles of ammonia cancel. Typing this into my calculator, I have 824 times 1 divided by 17.04 times 6 divided by 4 equals 72.535. And since I have 3 sig figs here, I will round this to 3 sig figs. 72.5 moles of water is the final answer for that one. And I got my final answer. So this is a mass to moles calculation. Now on the next one, we get to do a mass to mass calculation. And here it is. So tin fluoride is used in some toothpaste. This is often the active ingredient in your toothpaste to prevent tooth decay. and it doesn't occur in nature, so we have to take tin and react it with hydrogen fluoride according to this equation. So this equation is not balanced, and so we'll balance it. Down here I do have a little roadmap for how to solve this problem. I will activate the pen here. However, I do want to change the color back to blue because I think that makes me most happy. All right, so balancing this equation, I see that we have 2 fluorines here, but only 1 there. So I'm going to put a 2 there. Alrighty, now I have 2 hydrogens here, 2 hydrogens there. Boom, it is balanced. Okay, looking at the type of problem, we are looking for the number. There it is. We have 30.00 grams of hydrogen fluoride. All right, we'll start with writing that down. 30.00 grams of hydrogen fluoride. All right, so I know that my hydrogen fluoride is my A, it's my starting substance. And I like to provide as many visuals as I can for myself when I'm solving these problems to remind me of what's what when I'm doing things. Okay, now I have my grams of the substance written down. Looking for what we're trying to find, how many grams of SnF2. All right, so SnF2 is our B substance. Gonna give myself some room here. So looking for grams of SnF2. And now I have written that down. So this is a mass, grams to grams problem. So I'm just, now that I've identified what type it is, besides the fact that this is a mass to mass problem, but if I weren't using this as an example, I could recognize it as a mass to mass problem because I have grams here and grams there. I'm going to go ahead and follow my roadmap. Okay, so 1 mole of substance A, which is hydrogen fluoride, has a molar mass, HF. Hydrogen is 1.01. Oh, that's terrible. 1.01, and fluorine is 19. So the molar mass of hydrogen fluoride is 20.01 grams per mole. Okay. My next step is my mole to mole ratio. And I have moles of substance A, which is HF, 2 moles of substance B, which is SnF2. Now I need to look at what the numbers are, and I have a 2 in front of the HF. Again, that's coming from here, and a 1 in front of the SnF2. All right, I got that conversion factor down. Next, I have 1 mole of B, 1 mole of SnF2, and we're looking for grams. Now tin is, I do not have a periodic table handy. I'll see if I can see it from here. I'm going to have to be right back. Excuse me. I hope that wasn't too loud when I slammed it on the thing. All right, tin has a mass of 118.7, so I will just go ahead and add this up here. So 118.7 and 2 fluorines, and then we have 19 and 19. Oh, it's 118.71. So when I add them up, I get a 0.71. 9 and 9 is 18, plus another 8, so we have 26. 2, 2, 3, 4, 5, so 156 0.71. And using the Super Mario method of making sure we do our math right. Again, whenever Super Mario goes on the bottom platform, we divide, and whenever Super Mario goes on the top platform, we multiply. So, calculator, we have 30.00 times 1 divided by 20.01 times 1 divided by 2 times 156.71 equals 117.473763. I'm not sure if you can see this or not, but since I have 4 sig figs here, I need to round this to 4 sig figs, which is 117.5 grams of SnF2. And we have our last conversion factor there that we've used. Our grams of hydrogen fluoride cancel, moles of tin fluoride cancel, and we have our answer that we are seeking. So that sums up our basic stoichiometry problems. The next type is going to be looking at a little bit more complex type of problem called limiting reactant problems, and I will make another video of that. So good night.